Okay, today we're talking about the Pythagorean Theorem. The Pythagorean Theorem was developed by Pythagoras, who's an ancient mathematician from ancient Greece. Or his followers, which were called the Pythagoreans. It's not exactly noted on who found it, but it's used in a lot in building. Right triangles are the strongest geometric figure. So a right triangle is used as how you get your corners and diagonals across the room, things of that nature. And there are three parts. Two legs, one are the shorter legs of the triangle, and the hypotenuse, which is always the longer. The legs are interchangeable, does not matter which is which. And the Pythagorean theorem states that if a squared equals b squared, then a squared plus b squared is equal to c squared in order to be a right triangle. The Pythagorean triple is any whole number value that satisfies the Pythagorean theorem. And the converse would say that if you have three numbers and they satisfy the Pythagorean theorem, then you have a right triangle. And if you have three numbers that do not satisfy the Pythagorean theorem, it is not a right triangle. So looking at example 1, find the length of the hypotenuse. The triangle has side legs of 8 and 15. We're looking for c. So I take a squared plus b squared, and this is equal to c squared. This is the Pythagorean theorem. In this particular problem, 8 is a, 15 is b, and we're looking for c. So I plug in 8, and I get 8 squared. I plug in 15, I get 15 squared, and we'll search for c squared. 8 squared is 64, 15 squared is 225, and c squared we're looking for. 64 plus 225 is 289, and that's equal to c squared. We get rid of a square. The opposite operation of a square is the square root. And when you take the square root, technically here you get two answers, a positive and a negative 17. However, we're talking about a distance here of 17 inches, which is not possible ever to be negative. So these values, 8, 15, and 17 also are a Pythagorean triple, because they are whole number values that satisfy the Pythagorean theorem. Example 2 gives you A and C, where A is 12 and B we're looking for, and C is 13. Again, if we take the Pythagorean theorem, a squared plus b squared is equal to c squared, we can find out that 12 squared plus b squared is equal to 13 squared. We're going to keep in mind all of our solving equations. 12 squared is 12 times 12, 144. B squared we're looking for, and 13 squared is 169. If we subtract 144 to get b by itself, we're going to have b squared, which is equal to 25. The opposite, again, operation of a square is the square root, which gives us a b value of 5, the square root of 25. And again, 12, 5, and 13 is a Pythagorean triple. Lastly, given three lengths, 9, 12, and 16, is this a right triangle? That's what we're trying to figure out. 9 and 12 are interchangeable. They're the legs of the triangle, and 16 must be the hypotenuse. We know this because the hypotenuse is always along its side. So I'm going to say that A is 9, B is 12, and C is 16. Which would mean 9 squared plus 12 squared is equal to 16 squared. Or 81 plus 144 is equal to 256. 81 plus 144 is 225, which does not equal 256, which means, since they're not equal, this is not a right triangle, because it does not satisfy the Pythagorean theorem.